Have you ever heard of MediaWiki? It's a huge and popular wiki platform compatible with PHP 7 and HHVM from Facebook. And what about Peachpie? It's an open source .NET Foundation project that compiles PHP into .NET binaries. Here you can see some samples decompiled to IL and a bunch of benefits such as bridging C# and PHP, .NET build and diagnostic tooling, security or increased performance. So how about migrating MediaWiki to .NET using Peachpie and then running it on Internet Information Services, which powers Azure as well? Here I have all the MediaWiki source files downloaded from their official repo, including their default skin, Vector. Notice there are also composer dependencies specified in the included composer JSON file. Additionally, I downloaded composer.far, which manages the installation of these dependencies. So we also have to download the dependencies. And this is actually the only task for which we use regular PHP 7 because Peachpie is just not ready yet for the composer. Running composer.far with the parameter install and additionally nodev will do the trick. We'll do the same in the vector skin directory. Well, now we have all the sources, and I as a .NET developer would like to compile it. So we also need a project file. So let's create one, and it will be a special one. We prepared a simple project file that is understood by the .NET Build System and Visual Studio. Save it as something with the file extension msbuildproj in our project folder. Notice we optionally specify the output assembly name, then the required framework, which is .NET 4.6, and we'll build the library. Most interestingly, we indicate to compile all the PHP files, which is pretty unusual. And the entire Peachpie compiler and runtime are bundled in the NuGet packages Peachpie compiler tools and Peachpie.NET SDK. For the integration with IIS, there's the NuGet package Peachpie request handler. It provides the ASP.NET pipeline interface. First, just to be sure, let's download the NuGet packages. And try to compile the entire project into .NET. Okay, we can see that there are some fatal errors in the project, which we have to fix first. This is something that would just not work in runtime, and thanks to the compilation step, we can fix it even before it happens. Right, in this case, there's a use of the parent keyword in a class that does not have any parent. Just comment it out or something. This piece of code would never work anyways. Let's build it again. Now it will take some more time since the compiler can proceed to the compilation itself. Nice. 151 errors and some warnings. As we're looking through the build output, we see a bunch of unknown classes and lots of warnings. There are serious errors like returning a non-string value from the toString function, which would cause a fatal error during runtime. Most of the errors are in MediaWiki tests or a special maintenance folder or other package tests, mostly because they require a test framework, which we didn't include in the compilation. So let's get back to the project file. First, we suppress some warnings we really don't care about. Then we exclude all the tests and other files we don't want to have and which cause issues, including some composer plugins, etc. It took us some time to really exclude those files that are not needed and that cause the errors. After we save the new project file, let's test it again. Just one more thing. There's one source file in MediaWiki that has to be modified in order to work properly on .NET, parser PHP. In this file, they use a lock mechanism relying on PHP's deterministic garbage collection, where every variable is destructed when its function scope ends. This is not how it works in .NET, so we just comment out everything that locks using this method because it would never unlock. Good. So in the meantime, the project compiled without the errors. So recompile it again with the modified parser PHP file. No errors, a few warnings, and a new bin folder containing a bunch of DLL files, including our MediaWiki DLL and also a PDB file with debugging information, just like we are used to from C#. Actually, we can decompile the DLL file and see what's inside, for example using the ILSpy tool, which reveals what's inside .NET DLLs. PHP compiled DLLs are weird and contain all the PHP classes nicely compiled. The classes contain a few unusually generated fields and methods in addition to the normal ones. These are in general for purposes of the runtime and to provide compatibility with PHP. The function bodies are compiled into this nice set of IL instructions, which we can see and somehow decompile to its C# equivalent. There are also namespaced PHP classes placed within .NET namespaces, so it all looks like it would be written in the C# language, and you can eventually reference such a DLL in a C# project and use this PHP classes in C#. Jesus, MediaWiki has a ton of classes. Then there are specially namespaced classes prefixed with the root text. They correspond to script files and their global code. Every compiled PHP file is there, so we can find it and, for example, include it or invoke it in response to a web request. Now we have to utilize the compiled DLL and invoke the contained script files in response to a web request. In this tutorial, we use IIS7, which is built into Windows. So first, we create the well-known web config file. It is full of various configurations, and we have some .NET binding tricks that we can just ignore. It is important to define a handler for PHP files using our request handler package. It will pass requests to PHP files onto the compiled DLL file. Also, we define the default document to be index.php. Then the runtime section fixes some issues with referencing various versions of the same assembly. And finally, the system web section allows us to disable some validations, since MediaWiki is happy to use restricted characters in URLs and post requests. Let's save it as webconfig within our project folder. Now we can proceed to Internet Information Services. Simply add a new website. Let's name it MediaWiki, and specify the path to the website. We choose some random port to run the website on locally, like 5006. Also make sure it is running on a worker process with .NET 4 using the integrated pipeline. Now the site is actually ready. Everything seems to be configured, and additionally you can configure a bunch of other stuff here. We can open the website on localhost 5006. And here we go. We can now proceed to the installation of MediaWiki itself, which now runs fully on .NET. Everything is the same as in the normal installation, which is actually the purpose, to have at least the same experience. Except for the version of the runtime, which is now suffixed with Peachpie. Here we're supposed to connect to the database. As of now, Peachpie provides the MySQL extension. I personally use Docker and a running MySQL server in there. So there's this magic command to run the MySQL server on Docker. Here I just specify the name of the initial database to MyWiki and the root password. It just has to match with the information passed on to the installation form. Let's choose UTF-8, why not? Fill in the rest of the form, enter the password with at least 8 characters, and some email. Disable emails. We don't have an SMTP server on this machine anyways. Now the database is being initialized and the installer generates a setting file. And here we go. Some warning, Peachpie is probably doing something wrong, but as long as it's working, it's okay for now. And now the important step. Before we enter our newly installed site, we have to copy the generated local settings file into the project folder. And since the sources of the project have changed, we should stop the web server and compile the project again, now including the local settings file. Now let's build again. So since we're here again, we can take a look at some other warnings. Notice most of them warn us about the use of a function or class that is not defined. This is because Peachpie currently does not provide them. In this output log, we can check them and eventually implement them as part of Peachpie library. So, now we can start the web server and proceed to the MediaWiki main page. The first page always takes some time since .NET is performing just-in-time compilation and lots of things are being cached. Anyway, this is it, MediaWiki as a .NET process. We can see the W3WP process running. This is the IIS worker process running our website. You can see how it utilizes the CPU when we perform web requests. This is important because we can debug the process in Visual Studio. Ensure Visual Studio is in elevated mode, and then you can attach to the W3WP process. Starting now, we can take advantage of all the .NET and Visual Studio goodies. See the output pane. This is something like the PHP log, but fully integrated in .NET with many more features as you are used to from C#. Eventual debug assertions, etc. are recorded here, and you just have to attach the debugger. You can also open any compiled PHP file and put breakpoints in it. They all behave like C# files in the eyes of the .NET runtime and debugger. You'll see local variables, the call stack, etc. And also you can step through the code as usual. My favorite feature is the diagnostic tool. In real time, we can monitor memory and CPU usage and eventually record CPU profiling in order to see what's going on. And that's it. I hope you find running MediaWiki on .NET interesting. You can use this sample as a tutorial to run other PHP apps on .NET or .NET Core, or to bridge them with your C# project. Let us know what you think in the comments, and happy coding!